end of chapter 8, we're introduced to what is going to be the rest of the semester. We're going to move from having two variables that we have been doing so far, right? Like in this example, to have, well, as many variables as you can imagine. I'll start with just this little piece. It's in your textbook. It's towards the end, and it talks about a real world example of this tea production company in India that uses linear programming to better to enhance and to better control production and achieve higher profit. There's a few pieces of information here. So they have 120 different product lines, um, and they have different packaging. They have different types. They have let's see, they have 16 different gardens with 3 blending units, 6 packaging units, and 22 depots. That's in terms of the logistics of it. And then they have all the different ingredients. And then they have the distribution centers, which is, as you can see here, is about 325,000 retailers, etc. So this company actually used linear programming successfully to improve their operations. When you put all this together and you write it down on a linear programming problem, you get, according to this article, you get a linear program with 7,000 decision variables and 1,500 constraints. No, we're not going to go to that point. I think the highest we'll go is about maybe 60 constraints and about 20 unknowns or so. We'll not get to that level, but it's quite remarkable. And just think of the amount of human brain power necessary to solve this problem if we didn't have computers. But we do have computers, so we don't have to worry about that. And so let's just jump to it. So let me show you. I'm going to start with my template because, again, I want you to use my template, okay? I'm going to start here. And as you can see now, I have this problem which I got from your textbook right towards the end. I think it's page 330, 331. But that's basically what it is. So I think this is an advertising problem. I'm just looking at it. Yeah, it's an advertising problem where you have M stands for marine equipment distribution. No idea what that means. B stands for business equipment distribution. R stands for national retail chain distribution, and D direct mail. Okay, so these are all the different channels that you can use to advertise some product, and you're gonna have a budget, and et cetera, et cetera. I won't go into the details. You can read them. But how do you convert this monster? I'm sorry, this monster into this little guy, or this little guy into that monster, probably. So this is how you're gonna do it. Okay, it's gonna take a lot of little steps. So first of all, how many unknowns am I going to have? Well, I have M, B, R, D. That's 4. Okay, so I can name them just so we can keep good track. B, I'm going to need how many more? 2 more. Okay. That's going to be R. That's going to be D. Okay. So what are my coefficients? Well, they're 90, 84, 70, and 60. Okay, so now I have to fix this, right? Make sure that you delete things that you don't need, etc. Okay. Now look, you see, because I didn't copy and paste or drag my formula, this formula is right now incorrect. It's only looking at these 2. Okay, look, I'm gonna take the ranges and I'm gonna expand them. Okay, done. The upper part is done. Okay, now this has to move a lot. I'm gonna move it over there. All right, so now I'm going to have 4 constraints again. So I'm just going to create like, okay, like that. Yep. And I'm going to move this down because I'm going to need a space. You'll see why in a second. And I'm actually going to delete this. I don't need that. Okay. Okay, so I'm going to enter the first constraint. So it's going to be 10, 8, 9, 15. Less or equal than 5,000. Done. Second one. 2, 3, 3, no D, so 0. Less or equal, ooh, that's incorrect. Less or equal, incorrect, right? Of course. To 1,800. Okay, 2, 3, 3, 0. Okay, good. Number 3, 1, 1, 1, 1. That's like a budget. So 1, 1, 1, 1 has to be equal to 600. Oh, look at this. We haven't done, ouch. We haven't done one of these yet, right? Like a just a pure equal. It's not going to be a problem. Should be pretty easy. And then I have my my unknown, I'm sorry, my non-negativity constraints. So I'm going to need 4 because I have 4. So let me just wipe that out. All right, you see what I just did there? So this one, M has to be greater than 0, B has to be greater than 0, R has to be greater or equal to 0, I'm sorry, and D has to be greater or equal to 0. Okay. Now we're going to go down here, and this one is going to need some adjustment as well. Okay, so my right hand side is going to change to these guys. So I'm going to copy them, I'm going to paste them. 5018, okay, good. Now my formulas, let's take a look at my formulas. Oh, you see they're incorrect as well, right? Because before it was for 2 unknowns, now it's for 4 unknowns. So we need to adjust our ranges accordingly. So all I'm doing is I'm expanding them. And because I did it to the first one, it should be good for the rest. Let's just take a look. Looks good. I need 2 more constraints. So careful when you copy and paste. Okay, are they good? Yep, they're good. All right, I think this is it. I think this is all set. So I'm going to go to data, solver. Okay, so set objective to yes, to that one. Maximize, yes. By changing variable cells, well, that needs to change. You see, because before, again, it was for a 2 unknown. So now I'm going to select this whole range, right? This whole range, because I need Excel to figure out the value for all 4 of them. And then I'm just going to delete this and start from scratch. Okay, my first constraint is going to be these 2 guys right here. These 2 are less or equal to these 2. Okay, see that? Okay, my next constraint is going to be constraint number 3 is going to be equal to this, to 600. And then I'm going to add my non-negativity constraints because I'm a little crazy. All of these guys are greater or equal to these values. Okay, I have my constraints in, make a constraint variable, a variable is non-negativity, simply, okay, solve. Of course, now I just noticed that I forgot one constraint right here, and you've probably been screaming at me watching this video. I'm sorry, I forgot one. Okay, we need to fix this. Let's get to it. So R is greater or equal to 150. Okay. Greater or equal to 150. Okay. 1 R. Whoa. Wow, lots of mistakes, huh? But I catch them, so that's good. R. Okay, that's good. So now I have, let's see, so 1 R, and then I have 1, 1, 1, 1, 1. Okay. I just need one more here. Let me see my number 4. How is my number? So number, this one is 150. No, this is off. This is off. Okay. 2, 3. Okay, you see how everything went off? Got all, yeah. All right. Okay. So I'm just gonna delete the end. Okay. I just want to make sure that I'm doing it right. So and you are a 0. Okay. 26, 0, 1, 2, 50. Okay. All right. Let me run it. But I need to add the new constraint that I just added, which is this one. Is what is it? Greater or equal to 150. 1 to 150, which is right here. Okay, so that's good. That's good. That's good. That's okay. Good. Okay, and that is your solution. So you're going to use 25 of M, 425 of B, 150 of R, and no D at all, and the total max will be 48,450. So that's how you're going to convert your two variable, your two unknown into a four unknown, or 5 or 6 or 7 or 10. It doesn't matter, okay? It just keeps growing and growing and growing. Just use my template, or if you want to create your own, if you want to start from scratch, just make it look identical to mine.